So, thank you very much. I will not indulge further, and for me, especially it's like a pleasure to have a Singapore chapter of Incosi for the affinity and the previous history. And I can see some nice friends and ex member of the chapters. So, very happy to be here. And so today, as you mentioned, we are going to present. Let's say we're going to give you an overview of the book, the model-based product line engineering, and that leads me to the agenda. So the agenda follows the structure of the book, and we have like the introduction. So we introduce the topic and the motivation, because everything that you start must have a motivation. If you don't have a motivation, you are just performing activities, right? So that somehow are disconnected with each other. So you need to have a motive to implement anything you want, not just in engineering organization, but also in life, right? That's the same for MBPLE. Then we go on the foundation, because as everything, you need a stronger foundation, a proper foundation to be able to build something on top. And then we go on the implementation. So after you have acquired those skills, you are probably ready to start implementing it. But implementation is different than adoption, because you can implement it on a small scale and you can set up the basics. But then in order to have the model-based product engineering be adopted and scaled within an organization, that you need to adopt it properly. And since we didn't want to just remain on a theoretical level, we decided to include 5 industrial cases from 5 companies that have been doing product line engineering, model-based product line engineering in their own, sharing commonalities and also having differences that depends on the company and the type of business and the maturity that they have. Finally, like everything, we have a conclusion, and I hope it will trigger some questions and inspirations on your side. I will quickly introduce myself. For those who don't know me, I am Marco Forlingeri. I lead now product line engineering with pure variants within PTC. And I have the biggest pool of experts in the world, probably on product line engineering, since we have 14 people. I have around 14 people under me that are full expert on PLE. But I also have experience in other contexts and geography, as I mentioned before, like Singapore with IBM, before Airbus. And I lead the Incosi product line engineering working group. Maybe I just pass it quickly over to you guys. Tim?
Yeah, hello. Hi, I'm Tim Vikings. I'm consultant and trainer for MBSE at OSI. We are a consulting company in Germany, but we are delivering our services worldwide. And I'm in particular specialist of SysML. I'm one of the co-authors of SysML v1 and also one of the co-developers of SysML v2, currently leading the revision task force for SysML v2.1 or co-lead. And I'm also an author of this book, MBPLE. And with that, I hand over to Guillermo.
Thank you, Tim. Hello, everybody. My name is Guillermo. Guillermo Chalet will be the short version. I'm actually head of product lines and MDAO, that's multidisciplinary analysis and optimization at Airbus. I've been working on SC, MBSE, PLE, MBPLE for more than 25 years now. That's a long time. In the automotive, defense, aerospace, and railway industries. I'm also the founder and former chair of the PLE International Working Group of Incosi and of the automotive working group of Incosi too. And I'm very, very glad to share with you today this presentation.
So thank you, Guillermo. So we start with this sentence. So everybody agree with, at least with the 3 of us. And we also run a panel that had this title at the INCOSE IS in Ottawa in July, where the three of us were on the stage. And the key question is that it's not a question, actually, it's really a statement. It's a bold statement that no organization builds just one. And even if you, because if you build just one product, one system, either you are building a commodity where the difference is only based on a price, the differentiation is only based on price, or you are building probably a big project infrastructure. What companies are just set up for this big infrastructure project. But even so, you still have variation, you still have evolution. Even in that case, you're not building just one, right? And if you don't do that, you'll be probably soon out of the market, because if you're not able to cope with launching new variants in the market and adapting to the customer needs and fulfilling the customer needs and the customizations that is required, then you will be probably be soon out of the market. And this applies to multiple industries, like defense industries, aviation industries, consumer products, trains, automotive, and industrial machines like crane systems and others. So this is basically not just a problem of one specific industry, but is a problem across industries, right? So no organization will build just one. And how do they build their products, right? So that's the second question. If they don't build just one, how do they usually build their product? Well, that's what we try to answer in the book. And this is the cover. And as you can see, you have 5 companies that co-wrote the book with us and presented their cases. And the Airbus MBDA RTX with Raytheon subsidiary, Thales and Belimo. And those companies are in the defense, aviation, and industrial domains. Okay, so that's what we have as leading cases of the book. And all of them, what do they share in common? They share that they had to reuse. They had to build more than once, and they had to find a way to improve the way of working, the way of developing more than one product, more than one system, by reusing it, by doing it more efficiently. And that's where the motivation comes from, okay? So, and this is a motivation that comes from not just the companies I mentioned to you, but also I like to show this example because I started using when I was at Airbus, and I ended up using and reusing it because I think it's a relatively clear and simple example that show you why companies reuse and why they are forced to reuse. Okay, so let's have a look now at the example. So here you see 2 different type of products that are basically developed for 2 different type of customers. But there is a lot of reuse in the animation. You can see that the animation is pretty much the same. There are some adaptation to the scenery, to the background, and of course, all to the characters. But the movement and also the symmetry of the environment, it's basically the same, right? And well, this is not just a reuse of the drawing or the sketches, really a reuse of the full animation, of the full sketches and the sequence of those sketches that make the animation. Now you may think this is an isolated case in the Disney realm, but it's not the case. So if we go move forward with the video, we can see that in the entire Disney filmography, we have similar examples. So similar example of reuse of the animation between movies. And of course, you have probably never noticed that if you don't know the video, and as a child or with your kids, you have probably never remember that this has been reused from another scene, right? Because this is exactly the power of customization, trying to show, to create something new by reusing. Now, I could show this video over and over for the next 20 minutes. We have plenty of examples, but then we will probably eat up a lot of time to this presentation. So I'm not going to do it, but you can find it online by Googling Disney reuse, okay, on YouTube. Now, the question here is, how did they do that? Okay, so how did they do that? Well, simply, they got a sketch, fully animated sketch, and they reused the animation that was already tested, and they started to editing on top, to adding things, okay? So how does it work? Well, it's what we can call copy and paste, clone and own approach, right? So you have the first sketches of the animation, you make a copy out of it because you think you can reuse it, then you own now the copy, and you start making the changes to customize it, right? So you start to add elements, eliminate elements, or change elements. Now, the same way you can do it to one animation of a Disney movie, this approach works also for a requirement specification, for a test plan. It works for a model in MBSE if you use MBSE, or other alternative so modeling practices. So the approach is always the same. So you copy something, you own it, and you start changing it, right? So now the question here is this approach efficient? So what are the limitations of this approach? When this approach works, where it does not work? Well, very simple. So let's pause for the moment here and let's remember this question: when and where this approach works and does not work. And let's now look at a second way of dealing with variability and somehow tracking what has been reused. And this is what we call applicability matrix. We can call it product matrix. We can call it configuration matrix. Different names, same concept, okay? So here you have usually what we have seen. You have on your horizontal axis multiple products, variant of the same products, and you have on the vertical axis the capabilities, the requirements, the features, the components, whatever you want to focus on. And you just say the components, the capability, the feature applies or does not apply to a specific variant of the product by crossing the box. Now, again, this is a way to track the variability, and I've seen also variants of this approach. For example, in a requirement management tool, I see companies that use requirement management tool like doors, very famous doors from IBM, and they start to create custom column in doors, replicating the same approach in the requirement management. Again, it works, it's simple, but what are the limits of these approaches, right? So what are the complications that can generate out of this? Well, first of all, I have to say something, and this I borrow from my friend's team, that what we are developing, the system that we are developing, we talk a lot about, we have buzzwords like software-defined things, software-defined vehicle, and more AI in our products. These are not just buzzwords because this is the reality that we live and we face, right? So it means that the capability of our system becomes more and more advanced. But in most of the cases, I've been in Singapore for almost 3 years, and I've seen companies in Singapore, not only in Singapore, all over the world that use still Excel and Microsoft Word to deal with complex systems. And even if the capability of their system are high, the tools that they use don't match the capability of their system. So we have a gap. Who is bridging this gap? Well, the system engineers. Usually system engineers are those that bridge this gap. And thanks to them, we are still able to deliver a successful project. But at which cost, at which effort? No? That's always the same question. Now, this was a bit the motivation, and I wanted to set up the stage. And I'm happy to hand over now to Tim that will go through the foundation and will explain why some approaches like clone and own applicability matrix may not work. Please, Tim.
Okay, thank you, Marco. And you control the slides, right? Well, you can click. I think that's easier if I now change the sharing.
Okay.
Do you click?
Okay.
Okay. Yeah, so a similar figure to that what Marco showed before, with this instrument of torture for the systems engineers who got longer and longer. Well, complexity is certainly the biggest challenge of that face the companies now. It's huge, it's growing, it's highly dynamic, and it cannot be solved overnight. We have this project complexity with multi-location, new technologies, and so forth. The disciplines are merging more and more together. So each discipline has also to consider all the other disciplines, which increases the complexity. But at the same time, well, the engineer's brain, well, we have evolution, but it's not that fast as the complexity grows. So of course, we can then add more engineers to a project, which is maybe a good solution at first glance, but this increases the project complexity. So more people does not help very well to reduce complexity in a project. So what can we do? Well, we can follow this shift from document-based to model-based, which we observe not only here in the PLE world, but also in the systems engineering world and also in other engineering worlds. So next slide, Marco. Here's the text for that, what I told you. Yeah, another figure. The vertical axis is, again, the complexity, and the horizontal is the number of variants, so the degree of variability in your product line. And well, if you don't have much complexity and don't have much variability, you can do clone and own. It's not per se a bad approach. You can do this. It's another tool in your toolbox, but when it works well with low complexity and low variability. But most projects are not in this area. No? And the next step is this applicability matrix that Marco introduced. And then finally, well, we have MBPLE. Now we have high complexity and a high number of variants. Then you need, well, you should use MBPLE to master all the challenges you face in those projects. So MBPLE, there's a combination of two approaches. One is the model-based approach, so store engineering information in a model and not in Word or any other document. Storing engineering information in a model means you make it accessible to machines. Well, the tool now understands the content. It understands, oh, this is a requirement, and this requirement is derived from another requirement, and then the tool can support you. If you have the same information in Word, well, then the Word tool sees, oh, there's a nice text. Maybe we can do this bold or left aligned or right aligned, but nothing more. It doesn't understand the content. That's the model-based approach. Model-based systems engineering is there since more than 20 years, and it's increasing. And then we have PLE. It was also there before model-based. So there's this, let's call it traditional PLE world. But in combination then with model-based, then we have this MBPLE. Now we have this, what's shown here in the blue box, the model-based advantages like traceability, consistency, efficiency, and at the same time, product line engineering with the reuse of the assets. Yeah, next slide, please. Yeah, the background, we have standards, important standards. The ISO standards, there's an old one from 2015 on the left side, which introduced the domain and application engineering levels. And then, well, it's a kind of evolution. The newer one from 2021, the ISO 26580, which is about feature-based product line engineering, and still has the names of domain and application engineering. So it's not a complete new, it's an evolution from the previous standard, and it focuses on the model-based approach. Yeah, let's have a closer look on how to implement this. So the following is mainly based on the ISO standard 26580 on the right side.
Okay, sorry.
Yeah, no, you can click forward.
Okay, good. Yeah.
Yes, which shows the standard in another way, with the main pillars that are part of the standard. In the upper right corner, you see the feature model. The feature model lists all the characteristics of a product that varies in the product line. So we have these typical feature trees. You see examples on the next slides. And we have the feature configuration, which says, okay, this is a valid selection of features. Now for a car, now this is an automatic car with electrical engine and blah, 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 and so forth. On the left side, we have the shared asset supersets. That's the biggest pillar here in this world. It contains all our engineering artifacts, and they are all the digital engineering artifacts. So all our models, all our system models, but also the CAD models, simulation models, the source code, the requirements models, and so forth. That's here in this pillar on the left side, called shared asset supersets. And they cover the whole product line. So every variation is covered here in the shared asset supersets. The shared asset supersets, so the variants there, they are linked with the features. So we know, okay, for this feature, we need these engineering artifacts. And with this information, we can now, with the help of this magic PLE configurator in the middle, automatically derive product models. So a set of models specific for a single product, that only contains the information we need to build this product of the product line. So this is, in a nutshell, the ISO 26580 approach. Yeah, next slide, please. Yeah, we derive from this MBPLE paradigm, which is part of our book. There are 4 steps in there in a logical order. That's not the execution order in the project. It's more a logical order. So first, we define the feature models. So define the variability of your product line. And second, then click. Yes. Then you define the shared asset supersets. Now that's the big one. There are your SysML models, CAD models, source code, and so forth. And then third, we define the feature configurations. So a valid set of features specifying a single product, which also is then a definition of all the products in our product line. We can have many, many combinations, but we decide as a project for this product line, we have only 5 products in there, or 6, or whatever. So we will not provide all the possible combinations to the market, typically. Yeah, and finally, we can then, with this magic PLE configurator, derive the product models from the shared asset superset. Okay, let's have some concrete examples. Here's a feature model in pure variance. So on the left side, you see the feature tree for a drone. For example, the top level feature is a range. It's mandatory, and you can select between standard range and extended range. Another feature is about the mission. We have a delivery mission for the drone, or inspection, or monitoring, and so forth. Now, this is a feature tree. A feature is not a requirement. A feature specifies the variable characteristics of the product, and that's it. So next slide. Now we are in the shared asset superset, and I'm a SysML guy, so this is SysML. Actually, it's SysML v2. SysML v2 is special because it's one of the first engineering modeling languages that explicitly introduces variability. You see at the lower part of this view the keywords variation and variant. So the whole thing here is a breakdown structure of the drone. The drone is here in the middle, embedded in the drone system on the top. And the drone has engines, batteries, and a body. And let's look on the battery in the middle. There you see, oh, there's a battery, but it can be a standard battery or a power battery. And the battery is a variation, and standard battery and power battery are variants. So design decisions. Now, this is the shared asset superset. And variation and variance are part of the SysML v2 modeling language. Yeah, next slide, please. We are back in the feature world. We have the feature tree on the left side. And on the right side, you see feature configurations, typically done in a matrix. The columns are products or a valid feature configuration. So selected column is a delivery drone. And you see then, okay, we selected, it has an extended range. It has the delivery mission. It's for the Singapore region. And it has an extra payload feature. So this is a valid feature configuration, and the feature model or the tool assures that this is valid. Now we can define rules in the background. If you select this feature, you must also select that feature, and so forth. And then we can apply this, so a selected feature configuration, on our shared assets to derive the instances for a concrete product. And a shared asset, it's typically a model like SysML, CAD, and so forth, but can also be a Word document like this. So the Word does not contain variability constructs, so we have to define some meta information. Help us, like here, you see this keyword BP and var for the variation points and variants. And now a tool can remove all the texts in this Word document that are not part of the selected feature set. Yeah, but coming back to SysML on the next slide, in SysML we can then, in SysML v2, we can explicitly model also a derived product model based on a feature configuration like this one here. You see there's a delivery drone system X42. And well, that's now a lot of this might be too detailed stuff, but you see at the lower part, we have 6 engines selected, we have the power battery, and at the bottom we have the large payload attachment. So that's the selected ones for this product delivery drone system. Yeah, and I think with that, we have one more. Yeah, there's no talk without AI nowadays. And that's really important, right? There was a great keynote at the NCOSY symposium from Langdon Morris that showed us that, well, time is running fast. And AI is a really fast topic. It's really, really important. And it's, of course, one of the other key technologies to MB to master complexity. But it's out of the scope of this presentation to dive here into more details. I only want to mention that, well, of course, AI is a good helper, a good assistant in the area of MBPLE. But now with that, yeah, I pass the torch to Guillermo for the next topic.
Thank you very much, Tim. So what we've seen is the motivation to move to MBPLE, the foundations, and now, boy, oh boy, we're going to talk about how to do it in the real world. So Marco, if you move ahead. So there's, first of all, something that we included in the book. There's a lot of more material than what you see on the screen, of course, but this is one of the ways in which, if you need to justify a business case for MBPLE, you can try to use this type of graphs. The one on the left represents, in a blue line, the business as usual or the clone and own approach. I'm sorry, the yellow one. In the clone and own approach, as we said, well, you get very few benefits from that. And normally what happens in large companies is that the cost development from one product version to another is practically the same. So you can do continuous improvements, you can do a lot of things, but since you're always going to, like it was explained at the beginning, modify or tweak a little the product that you're copy and modifying, then you will induce higher costs for validation, integration, and so on. While the blue line represents what would happen with an MBPLE approach. Usually, normally, most of the things that you will find in literature will tell you that logically, the initial investment to do a product line is higher than that of producing a single product, which can stand as true. The other thing that you can see on the screen is that normally you don't get the 100% of the X million dollars or euros that you will need to develop your product line. You will get that little by little, year after year, a little bit more investment and so on. The point at which the two lines cross is your payoff point. That is the point at which you have got a good return of investment, and from there on, from that point to the right of the graph, the area between these two lines are the gains that you will get in an MBPLE approach. Now, these curves are very simplified, but you can imagine that it's not only linear with MBPLE, it's a super linear approach in which, as we will try to explain a little bit later, the more you do, the more you gain using an MBPLE structured approach. I will not dwell a lot on the curves on the right, but this represents, if you take a look at it very quickly, the cumulated costs for one product, for a product line, using typical approaches, for a product line in blue using MB model-based and simulation approaches, and the yellow line again with MBPLE. So if you think about it as a long-term investment, this is where really the gains can be huge when you go into MBPLE. Not just your first product, which could stand in the whereabouts of the same type of gain and investment as single product development. Like I said, probably a little bit higher at the beginning. But then if you think about your long-term business, this is where the argument for MBPLE is really powerful. If you move forward, Marco, thank you. Now, how do you go about this? Where do you start? Well, it really depends on your starting point, on the situation that you are currently going through. in this graph, what we try to represent is an adoption quadrant, meaning that most of us, most industries have started doing requirement-based or document-based systems engineering. From there, you can move in either one of two directions, either MBSE, which is already a good step, or systems engineering family, a product line, typical product line, without really using MBPLE as it is. Now, the bright idea that came up several years ago, but combining MBSE and product line engineering will naturally lead you, whether you took the MBSE approach first or a PLE approach first, to the MBPLE approach. There are ways to move around this. This is also explained in the book. We don't have the time to delve into details, but depending on the path that you use, there are different tips and advices that you can find in the book that we wrote to go in different ways and try to do it efficiently. Basically, what we did in the book is also talk about our own many mistakes so that you're not forced to go through them as we did, as where we have, or the companies that we have worked with have. One more click, Marco. In the book, you will also find that we explain clearly that in order for this to work, this is really not just a technical problem. You really have to deal with how your processes eventually have to be modified. You have to come up with specific methods. There's a difference between doing single system development and a product line development. You have to take into account different things. Just for instance, in the feature models that Tim was showing us previously, one of the starting points is what do you want to do with your market? In how many markets do you want to evolve? Do you have customer segmentation in those markets? And this gives you the first elements to start structuring a very good feature model, which as you can see, as I'm explaining to you, goes beyond the pure technical problem. So these new methods, this new way of attacking things is what you have to think about. Of course, we are talking about model-based PLE. So your information model, your correct data models, the way things are going to flow in the different activities of product line engineering with models has to be mastered and very well formalized. To make things work, to make the PLE factory that was shown previously, you will also absolutely need good tool chains. And last but certainly not least is the organization and the human factors. This is probably, in my experience, one of the most difficult things to do. Techniques and tools are kind of easy to understand. It's even an elegant approach if you want. But changing the way the organization is working, going through people's mind to understand their blockers, that's where the thing gets really, really interesting and probably more difficult, like I said. I'll try to just accelerate to give some time for questions. If you want to know more about what people are doing, what the questions are being asked, for those who have experience or those who have just an interest or started to work on PLE, we really encourage you to join the INCOSE PLE International Working Group. It is headed now by Marco and Roland Darbin from General Dynamics. So really go take a look in there. You will find many resources and of course the events that we organize on a yearly basis. We are one of the most faster growing groups for the last, 5 to 7 years since the group has begun. So really, really go take a look at it. You will find more resources. Last but not least, you have to know that this is working. It's not just us coming up with a bright idea and trying to convince you that this is a nice thing to do. It's really been coming into the mainstream, I would say, for the last 5 years or so. The business cases that we're going to show you and those that are included in the book will show you different aspects of MBPLE, either on the efforts and the whole story of doing this or on particular details on this. So here we're going to show you just two. If you go ahead, Marco. and we chose these two because those are two that I know very well. So the first one is just a way of explaining to you what does variability management mean. And we wanted really we asked Airbus to do and to put an emphasis on the whole different dimensions of variability. What you can see on the screen is that in these 4 different dimensions, there's first your product of interest. Now, most of the time, you will start with the thing you're selling. In our case, for commercial aircraft, well, those are aircrafts. Then you can say, okay, but I'm doing systems engineering for product lines, so I have to deal with all the enabling systems too. So there's also the inclusion of the industrial system and the services sometimes that will accompany your product offer, or if you're going in the other direction, your product service offer, which will lead you to better, higher profitability margins if you're going into services. Now you have the second one is different levels of the aircraft. You can think about the aircraft as a single system that you're selling. You can apply the same type of reflections for main systems or components and go even lower in your product breakdown structures up to elementary components or subsystems. All of these eventually can be affected and introduce new features or new variability criteria. Then when you start doing systems engineering, as you know, you have to take care of the operational, the functional, logical, physical layers, and all of these can introduce also different ways of formalizing variability. Just a very simple example. In Airbus commercial aircraft, we are very conscious that it's absolutely not necessarily the same to operate an aircraft in the Far East or in Southern Africa than operating in Europe or in the Americas, for example. And this gives you already a variation point, variation criteria there from the operational analysis. Then, last but not least, as you know, like Marco said at the beginning, we're not just building one, but we do talk about an aircraft family for our main families, A320, for example, or A350, which are the ones that most of you might know. Within these families, there are also variations in mission, that it means range, capacity, interiors, different cabin definitions, and all of this this is the intrinsic variation of your product offer that also has to be taken into consideration to have a complete feature model that represents how you want to run your business, actually. So this is the first example. There are more details in the book, of course. Given the time, I skip right to the second one, which is a very, very interesting story, long story, of ground radars for Thales. This was done for the civil and the military market. Now, one of the challenges that is explained clearly in this example is that to calibrate this type of radars, usually we used to need about 1 year, 11 months, 10 months of expert knowledge trying to do the right calibration of these radars. When we started doing product line engineering, it came up evident that some of the decisions that these experts were doing could be modeled using a feature model. So, long story short, this went from 11 months of needed expert time to actually about 4 hours now to calibrate, to do the same level of calibration for the radar. This means that our experts can now work on more advanced features, on doing more R&D implication and feeding the technology funnel of this type of product. So it's maintaining itself in a very nice way. What I can tell you about this is that at one point in time for this business of Thales, this was a survival thing. So what we also state in the book is that probably your company doesn't need to be confronted to this type of situation to react if you have the right arguments to do this, which will lead us to the conclusion, probably, Marco, if we want time for questions. Yes. So we gave you a lot of information. Let's try to have some takeaways. And guys, please step in whenever you want to complete what I'm going to present. A couple of takeaways for you. First one, there is a lighthouse, which is the new standard for MBPLE. That's what we've been using. That's the foundation for the book. There are more elements, as you have seen, but MBPLE takes really a good explanation and I would say a leverage point from these standards. Basic thing here, your single source of variability. You might imagine that if your mechanical teams or your control engineers or your systems engineers have different points of view on what the variability for product is, then you have very few chances of making the thing work. The second conclusion, which is one of the most interesting ones, is that the MBPLE factory is possible today, meaning that the basic capabilities for tooling, in particular for variability management and to put in place the MBPLE factory, are already there. This is something that you can keep in mind. Now, like we said, the question is how to make it work in your companies, but the basic capabilities that are needed there, be it SysML2, being pure variance for product for variation and modeling variability, are already there. This is a very powerful thing. And the last thing, but this I always make the joke to Marco, but this is a question for Marco, is that tool providers, ALM or PLM providers, still have to make us make this thing work. They still have to work together, all of us, so that if you need the full digital thread to make this work, there are still a couple of things that people need to work on. And I think that with that, Marco and Tim, anything else you would like to add before questions?
No, that's
Perfect.
it. Thank you, Guillermo. We would like to give 10 minutes time if there are questions. Yeah, I will.
Thanks, Marco.
Sharing.
Thanks, Tim, and thanks, Guillermo, for the introduction and overview. Maybe I would like to start with the first questions. I think most of the participants here, they are from INCOSE, and they are very familiar with the terms MBSE. And of course, I think Tim or Guillermo trying to explain in the quadrants, the matrices on how to progress from the MBSE to MBPLE, or system-based engineering to MBPLE. There are different pathways that an organization can adopt to become a MBPLE organizations. But I think is there really a difference? Maybe that I'm not too familiar with PLE. Is there really a difference between MBSE, or subtle differences between MBSE and MBPLE, or is the creation of the term MBPLE is deliberate? Because there's this really subtle differences between MBSE and MBPLE.
I can probably start with that one. Yes, this was done on purpose, of course. The difference between MBSE and MBPLE is kind of the same type of difference between systems engineering and PLE by itself, whether or not you're using models. Actually, if you're a good system engineer, I think most of us would understand that the system of interest, when you're talking about MBPLE, is a family of things. Like Marco said, you have to think about not building just one as early as possible or from the beginning. And the other differences were explained quite briefly by Tim is that the development of these things are based on an ensemble of shared assets, configurable shared assets that belong to the whole family and that encompasses every member, every product member of the family. Those and the last thing, which is I think key, is that variability has to be managed systematically and well, this is only Guillermo speaking, but in a quite efficient and disciplined way, you know, around the company to keep things under control. Those are the main differences to me.
Yeah, so, well, I totally agree. In MBSE, the system of interest is, well, if you look in books, it's mainly a single system, although we know there are many variants in the system, but they are in the background and they are not explicitly managed. And PLE or then MBPLE puts the topic of variability on a very high level. So we put an emphasis, or we emphasize the variability. So that's, I think, one of the main differences. I think it's quite interesting that the system of interest is a single system. So MBPLE should be the norm, not MBSE, at least nowadays.
Okay. Yeah, it's interesting that you guys talk about variabilities, product family, and definitely it's quite interesting. Marco started the presentation with the animations. Borrow from the Disney or companies. Definitely we so when we talk about the variability, right? Since both of you are from Airbus, right? And we always talk about this configuration variabilities. When creating different products or different tail numbers, every single aircraft probably there are variances and differences when come to features and configurations. How do you understand the difference between the product line engineering, or the variances that you talk about, which is addressed under, I think you mentioned ISO 26000 versus configuration management, which is always talk about, also used to manage different configuration variances under ISO 27000. Is there any clear differences between the variances that you talk about here and or the PLE, MBPLE, and configuration management?
Absolutely. We use the word product configuration, which is kind of different from what you understand in configuration management or talking about configuration items. As we said, a product line being defined by its ensemble of shared assets, each of these assets may or may not, depending on your company, become at a given point in time a configuration item for your overall configuration management. Now, the delicate part is not just handling this, is that you have to be aware that there's a configuration management space, you can call it that way, that concerns the product line, that is the whole family. And there are configuration management spaces that belong or that pertain to every single member of your family. And the connections between these two are very, very important and even delicate to manage. So there is a difference. We use the same concepts of configuration items and so on, and all the processes in configuration management. But we add another dimension here, the dimension of the product line and the dimensions of every single product instance, if you want, or product member of the product family. So we are aware of this double use of the word configuration. We haven't yet tackled that. Yes, we are tackling that in a future ISO standard of the 2658 family. It's still in progress.
Okay, thank you. Maybe that I want to hand over the time to other participants to ask the questions.
So thanks a lot, team, Gerion and Marco. It's Robert speaking here. So I just back from the hospital with a surgery, so I'm not able to join in the very beginnings. So thanks a lot for your times. This section we are recording it because we got some member requested they are not participate. We're going to share it at the community in China, Taiwan, and the other country as well. So it's a very interesting topic that a lot of people are very, interested in. So, we also get some question from a lot of people, right, who are doing the, especially the community from the architecture. They frequently ask the question that, when we do the variants on the PLE, always target at the abstraction level, the logical architecture. So it happens that a lot of people start with the E architecture, those community, they have their own logical architecture for the E architecture, right? We do also have the system engineer. Naturally, they are the ones start doing these variants. And they also have the system level of the system architecture. So in your opinions, right, between these two logical level, what is the more logical place to start to do these variants to support this PLE? Between the system abstraction level architecture or the EE logical architecture level? Because we found out these two community are competing each other, right? And both of them introduce their architecture, and both of them introduce the abstraction at the logical level. And happily, both of them also doing the PLE. Then when we talk about the MBPLE, one question they always come and ask is, who should be the one who doing it? Since whatever they do, the logical level is intersect. So what is your opinions based on your experience? Where should they start?
I have my opinion, but I will let my colleagues start first. I'm talking too much.
Okay.
So, well, the first thing that comes to my mind is that I'm not pretty sure if I fully understand the EE architecture stuff, but you have different levels now of feature models, so that a feature model can integrate another feature model. So, for example, we can have the feature model on the top level, on the system or PLE level, and then we have the feature model for the E architecture, and ideally it fits in there, so that they fit together. And the other thing that came into my mind is, well, I think the integration of the E architecture to the system architecture that's a general challenge independent of PLE. Now you also have this if you don't have PLE, how to integrate a discipline-specific architecture in the overall system architecture. So if this is not resolved, then you carry over this issue also into the MBPLE world.
No? I would add that this is my opinion, and what I've lived in different sectors is that doing PLE per se can only last for a couple of weeks in which engineers will have fun. I think that PLE without a proper strategy, some people call it product policy, some other people call it other ways. But if you don't link that to how you want, what position do you want to really take in your different markets, then PLE has no essence, because you are there. PLE is there to satisfy business requirements, how you want to grow and sustain your own business. So I would have the tendency to say, let's start there, because the rest of the things, I think we are good engineers. Most of the places I've been there, engineers are good. They are not doing a bad job. On purpose, and they will find a solution to satisfy this need. But if this need is not really stated, then we are letting them provide solutions for problems that probably don't even exist. That would be my take on that.
I just pasted a paper that may answer your question, Robert. In the chat.
I'm looking into it. Great. Perfect. So I will share this informations with the couple of customers who are interested in this topic and ask, because this question come with a lot of customer from the automotive industry. As you can see that a lot of them doing this software defined vehicle. And the one who responsible for this software-defined vehicle, for example, the ADAS and the autonomous drive system is actually spring out, right? And now this community is actually, interestingly, you see that the system engineer, what they're doing, and the E-architecture, what they're doing, is intersect to each other, right? Because the E have called for the software, and then the system architecture is mainly software and electronic, right? And signal. So they're getting really a lot of arguments, confusing discussions, right? The more we discuss, the more the people get into confusion.
And Oliver, Robert, the answer is they need to get pure variants, because
Right.
they need an holistic product line solution, right? So if you do it only in the domain specific tool, like it could be in the MBSE tool or in the E tool, or if you do it in the AutoSAR part, so it's always like a domain specific. So if you have a feature model in a tool that can connect, following the PLE approach, can connect with N solution, like give an example, for variance Cameo, right? So we have the connection with Cameo, we have the connection with Scade, we have connection with Zuken, we have connection with the software AutoSAR, okay? So that's why you need an holistic approach if you really want to tackle that. And then you will make everybody happy, because everybody can use the same feature model.
Yeah, so this is a very interesting topic. Anyway, we will try to look into deeper on that one. We will try to look into the opportunity to maybe even invite you guys come to China. So a lot of automotive industry in China now is really doing extremely well compared to the other company that is traditional building car, right? In the shorter time frames, more agile and more flexible, but at the same time, it's more ad hoc. So a lot of people start turning into, after this excel in the productions and efficiency, start looking into a little bit more formal, into more organized, more systematic. So now they start talking about the topics about, the PLE, the model-based system engineering, and how they are able to improve the efficiency even better with what the methods in the agile methodology they are applying, right? So we'll look into more on this opportunity, and maybe we will continue to invite into more consent groups into this automotive industry, and have you guys to talk about the MBPLE again. Right, so I think it's very wonderful times, and thanks very much. So Selway, back to you. I think this is the end of the presentation. Marco have to leave also. So any other final closing from you, shall we?
Yeah, thank you very much. Thanks team Marco and Guillermo to join us in this webinar and provide us the overview of MBPLE. And now if you guys, all the participants, if you have any additional questions, just remember that now Marco, Tim, and Guillermo has published a new book on MBPLE. I think that would be a good resources for everyone who are interested in finding out more about this particular topic. And I will provide the link to this particular book in the INCOSE website on LinkedIn.
In the Singapore link, yeah, we will provide the information, and we will share this video with all our members and our other members in the other Asian country with the link of the books together. So thanks a lot for everyone.
Thank you guys for hosting us.
Thanks, everyone.
All right, goodbye. Thank you.
Have a nice day.
See you all.
Nice evening. Bye-bye.
Bye-bye.
Goodbye.